So today in this class, let us solve some numericals. Let's read the first one. Find the polar moment of inertia of a solid circular section of diameter 200 mm. Also find the radius of gyration. So this section given here, the geometrical section given here, is a solid circular section. This is a solid circular section, and the diameter is given equivalent to 200 mm. Diameter is equal to 200 mm. Let x-axis of this solid circular section pass from here, and y-axis from this section here. Y. So this is my centroid G. Now we are asked to find polar moment of inertia and radius of gyration. So the first one, let us find polar moment of inertia. Polar moment of inertia. It is denoted by IP, and its formula is Ixx, which is moment of inertia about x-axis plus moment of inertia about y-axis. Right, so this is its formula. Now, for solid circular section, Ixx is equal to Iyy is equal to pi by 64 d raised to power 4. Right, so I have pi by 64, and diameter of this circle is 200 raised to power 4. So I get this equal to, let's calculate, it will be equal to pi by 64 into 200 raised to power 4. So this is coming equal to 78.539. So let us convert this 939 to 78.54. So it's coming 78.54 into 10 raised to power 6. So it is equal to 78.54 into 10 raised to power 6 mm raised to power 4. So this is my moment of inertia about x-axis and y-axis. Now let's find polar moment of inertia. IP will be equal to 78.54 into 10 raised to power 6, which is Ixx, plus 78.54 into 10 raised to power 6. So how much will we get? Let us calculate again. It will be equal to, let us do answer into 2. So we are getting 157. We can make 157.1 into 10 raised to power 6. 157.1 into 10 raised to power 6 mm raised to power 4. So this is your polar moment of inertia, or the moment of inertia about the third axis or the third plane, IZZ. Now next, they have asked us to find radius of gyration. To find radius of gyration, number 2, radius of gyration. Right, and it is denoted by k equals to root over of I by a. Right, since our Ixx is equals to Iyy, let it be equal to I, moment of inertia I, which came equal to 78.54 into 10 raised to power 6 mm raised to power 4. right? Now, how much will our area of a circle be? It will be equal to pi by 4 d raised to power square, which will be equal to pi by 4 into 200 square. Now this will come equal to, let us solve again, pi by 4 into 200 square. So we're getting 31.42 into 10 raised to power 3. 31.42 into 10 raised to power 3 mm square. Right? Now let's find radius of gyration k. Now k will be equal to, I is equals to 78.54 into 10 raised to power 6 divided by area is 31.42 into 10 raised to power 3. Now this will come equal to root over of 78.54 into 10 raised to power 6 divided by its answer. So we get 50. So the radius of gyration is equals to 50 and its unit is mm. So we have found out the radius of gyration for solid circular section, and it's equal to 50 mm, and the polar moment of inertia for this solid circular section here is equal to 157.1 into 10 raised to power 6 mm raised to power 4. Now let's solve the second numerical. Let's read its statement. It states that a hollow circular section of external diameter 100 mm has a uniform thickness of 10 mm. Calculate its moment of inertia with respect to number 1 diameter, number 2 tangent to the circle, number 3 the axis parallel to and 20 mm below the tangent. Right, so now for this numerical, I have already drawn the diagram here. It's a hollow circular section, and the external diameter of this hollow circular section is given equal to 100 mm, and it says that it has a uniform thickness of 10 mm, which means over here also the thickness is 10 mm, it's uniform. Okay. Calculate its moment of inertia with respect to diameter. Now, before we go into solving this numerical, let us find the internal diameter. Internal diameter D will be equal to, what I'm trying to do is I'm trying to find the diameter of this inner circle from here to here, which is, let it be small d. So this small d will be equal to diameter of the outer circle minus the thickness, right? So diameter of the outer circle is given 100 minus, and thickness from both the side is, from one side it is 10 and from the other side it is 10. So we need to take thickness from both the side, then it becomes 20. The thickness becomes 20, and this difference is 80 mm. So this is my diameter of inner circle, 80 mm. Now let us solve the first condition. It says find moment of inertia with respect to diameter. So first one, we have to find moment of inertia with respect to its diameter. So what does it mean? That we have to find moment of inertia with respect to its diameter. Now, as you can see that with respect to its diameter will be the planes that is running parallel to planes that is running in two direction, that is x direction and y direction. So if this will be, for this condition we need to find moment of inertia about ix axis and moment of inertia about iyy axis will be equal to pi by 64 d raised to power 4 minus small d raised to power 4. Okay, so this will be equal to pi by 64, external diameter is 100 raised to power 4 minus internal diameter is 80 raised to power 4. This will be coming equal to, let us solve it in a calculator. Pi by 64 into 100 raised to power 4. Oh, I'm sorry, 6. 100 raised to power 4 minus 80 raised to power 4. So the moment of inertia of this hollow circular section with respect to its diameter, it's coming equal to 2.89 into 10 raised to power 6. So it is coming equal to 2.89 into 10 raised to power 6 mm raised to power 4. So the first condition is solved. Now for the second one, it says calculate moment of inertia with respect to tangent to the circle. Now for this condition, we need to draw a tangent. Let us say that it has not mentioned the distance, so let us say that this tangent is running from this base. It is parallel to, it is a line that is running straight from here. Okay, so let this be the tangent, and let us name this tangent as tangent AB. Okay, now this tangent AB is running parallel with this x-axis axis here. So if we find the moment of inertia about this tangent, we are asked to find moment of inertia with respect to tangent to the circle. So the second one, we are asked to find moment of inertia with respect to tangent to the circle, and the tangent here is my line AB, which is running parallel with x-axis axis. So I have to find moment of inertia about IAB. Now here I have to apply parallel axis theorem, and since AB line is running parallel with x-axis axis here, so the formula will be equal to Ixx plus area of the hollow circular section into its distance and squared. So this will be the formula, right? Now what will be the distance h here? The distance h here will be the distance between these two parallel lines, which is this distance h, and this h will be equal to external diameter of the circle divided by 2, which is equal to 50 mm. Okay, now let us further solve. We have already found Ixx, which is equals to 2.89 into 10 raised to power 6. Now let us find the area of the hollow circular section, area of hollow circular section will be equal to pi by 4 d square minus diameter of inner circle square. Okay, this will be equal to pi by 4 into diameter of external circle is 100 square and the inner circle is 80 square. Now you will get, let's solve it in a calculator again. Pi by 4 into 100 square minus 80 square. So I get 2.83 into 10 raised to power 3 as its area. 2.83 into 10 raised to power 3 mm square. So this is its area. Now let us find. It will be equal to Ixx is equal to 2.89. 2.89 into 10 raised to power 6. This is Ixx. Plus its area is 2.83 into 10 raised to power 3 into its height here, h was equal to 50 mm. So into 50 square. So this one here we get equal to, let's solve it in a calculator again. So it is equal to 2.8. Let us do it in a bracket. 2.89 into 10 raised to power 6 plus 2.83 into 10 raised to power 3 bracket close into 50 square. So this is coming equal to 9.965 into 10 raised to power 6 which we can round it off and make it as 9.97 into 10 raised to power 6. So 9.97 into 10 raised to power 6 mm raised to power 4. So this is your moment of inertia about with respect to tangent to the circle, which is this line AB. Now third condition, it says the axis parallel to and 20 mm below the tangent. Now again we have to go, it says the axis parallel to and 20 mm below the tangent. Now this below the tangent, I have to go 20 mm below this tangent and it is parallel to this tangent AB. So that means another line parallel to AB, and let us name this line as, we can name this line as PQ, right? And it is 20 meter below this tangent AB, 20 mm below this tangent AB. Now if I have to find, since this PQ is also running parallel with XX axis, my distance between these two lines will be this distance h, this distance h, which will be equal to, from this line AB till this XX axis it was 50, right? So it was 50, and from this line AB till PQ it is 20. So 50 plus, it will be equal to 50 plus 20, it will be equal to 70 mm. Okay, so Now let us find the third one. Moment of inertia with respect to the axis parallel to and with respect to the axis parallel to and 20 mm below the tangent. So this will be equal to, since we have named this tangent as PQ, so we need to find moment of inertia about PQ, which will be equal to, PQ is also running parallel with x axis, so it will be Ixx plus AH square. This will be the formula. Again, area of the circle will remain same, only the h will change here. The h that we got was 70 mm. This 70 mm is this distance from this x-axis here to this line PQ, which is running parallel with x-axis. So this is the distance here, which is equal to, from here to here it was 50, and from here to here 20. So 50 plus 20 equals to 70 mm. Now if we find this one, it will be equal to, Ixx was 2.89 into 10 raised to power 6 plus area was 2.83 into 10 raised to power 3 into 70 square. So this will be coming equal to, let's solve it in a calculator again. 2.89 into 10 raised to power 6 plus 2.83 into 10 raised to power 3 into 70 square. So this is coming 16.76 into 10 raised to power 6. 16.76 into 10 raised to power 6 mm raised to power 4. So this is the moment of inertia about the axis parallel to and 20 mm below the tangent. I hope this numerical is clear. Let's solve the third numerical. The third numerical says, its statement states that find the moment of inertia about the axis AB for the given diagram below. So this is the diagram here, and let us name this triangle as A, B and C, right? And now we are asked to find moment of inertia about this axis AB. And for the triangle, let us say that the x-axis will run from here, x-axis, and from the base, this point, the centroid G will be here, and from the base it will be at a distance of h by 3. So how much is my h in here? My h here is, total height of this triangle is 200. So it will be 200 by 3. Right? Now we are asked to find moment of inertia about AB. So this AB line is running parallel with this axis, x-axis. So if I find moment of inertia about AB it will be moment of inertia about AB will be equal to, since AB is running parallel with x-axis, we have to use a parallel axis theorem. So it will be IXX plus AH square. So I have this formula again. Right? Now, what will be the moment of inertia about IXX axis for a triangular section? IXX axis for a triangular section will be equal to BH cube by 36. So how much is my B? From the diagram, my B is equal to 150. My B is equals to 150. So I have 150 into, how much is my H? Height of this triangle is equal to 200 here. So 200 cube by 36. So if I solve this in a calculator, let us see how much we get. I have 150 into 200 cube by 36. So I'm getting 33.33 into 10 raised to power 6. So it is coming 33.33 into 10 raised to power 6 mm raised to power 4. So this is my moment of inertia about x-axis. Now let us find the area. Area A will be equal to, area of a triangle is half base into height, right? So area will be equal to half base is 150 into height is 200. This will be coming equal to half base into height. This is coming 15 into 10 raised to power 3. 15 into 10 raised to power 3 mm square. Right? Now, the last one from the formula that we need to find is its height h. Now, what will be the distance h from for these two parallel line running parallel to each other? The distance will be this distance h. Now how much will h be? If we say that from the base, if our centroid for this triangular section lies at the height of h by 3, so the remaining portion, let us say from this apex till this point, the remaining height will be 2h by 3. So it will be equal to 2 into h is 200 divided by 3 will be equal to, let us solve it in a calculator again, 2 into 200 divided by 3. So this is coming equal to 133.33. So it will be equal to 133.33 mm. So this is my remaining height. So if I find the distance, my h will be equal to, from this point till here it is 133.33. Now from this AB axis another height is given, which is 100 mm. So if we find the difference of these two heights, we get this h here, right? So which will be equal to 33.33 mm. So the height h between these two parallel line running parallel to each other will be equal to 33.33. So if we find moment of inertia about IAB, it will be equal to, how much is our IXX? It is 33.33 into 10 raised to power 6 IXX, plus area is 15 into 10 raised to power 3 AH square. H is 33.33 square. Right? So this is the final expression. Now let us solve this into a calculator. So I have 33.33. I'll do it in a bracket. 33.33 into 10 raised to power 6 plus 15 into 10 raised to power 3 into 33.33 square. So I'm getting 49.99 into 10 raised to power 6. So it is coming 49.99 into 10 raised to power 6 mm raised to power 4. So if you approximately, this value will be equal to 50 into 10 raised to power 6 mm raised to power 4. So your moment of inertia about this line IAB is equal to 50 into 10 raised to power 6. Coming to the fourth numerical, let us read its statement. Calculate moment of inertia of the figure given below about PQ axis. So the axis here is PQ axis, PQ axis here, and this PQ axis is running parallel with this axis, XX axis. That means in here also we need to use parallel axis theorem. So by parallel axis theorem, moment of inertia about PQ will be equal to IXX plus AH square. So by parallel axis theorem, I get this. Right? Now, since this geometrical section given here is a semicircle, half of a circle, so my moment of inertia about XX axis for a semicircle will be equal to 0.11 r raised to power 4. So how much is my radius given here? It is given as 75 mm here. So my 0.11 into 75 raised to power 4 will be my moment of inertia about IXX axis. Let us solve it in a calculator. Zero 0.11 into 75 raised to power 4. So this is coming equal to 3.48 into 10 raised to power 6. It's coming 3.48 into 10 raised to power 6 mm raised to power 4. So this is my moment of inertia about IXX axis for a semicircular section. Now we need to find area of a semicircular section will be equal to pi r square by 2. So here again, pi into radius is 75 square by 2. This will be coming equal to pi into 75 square divided by 2. This is coming equal to 8.84 into 10 raised to power 3. 8.84 into 10 raised to power 3 mm raised to power square, since this is a area square. So now I only need to find the height h. H height will be this distance h, right? Now for a semicircular section, its centroid G will lie at a distance 4r by 3 pi. At a distance 4r by 3 pi. So my whole of this is radius r. And I need to find only this height h, which is from here, this point to this. So my h will be equal to r minus 4r by 3 pi. So how much will this be coming? This will become equal to radius given is 75 minus 4 into 75 divided by 3 pi. So this will be coming equal to, solve it in a calculator again, 75 minus 4 into 75 by 3 pi. Oops, sorry. 3 pi. So it is coming, height is coming equal to 43.16. So let's make it 43.2. 43.2 mm. So we have all the required values. Now let us find the moment of inertia about moment of inertia. We are asked to find moment of inertia about this line PQ. So PQ will be equal to moment of inertia about axis was 3.48. It was equals to 3.48 into 10 raised to power 6 plus area of the semicircle came out to be 8.84 into 10 raised to power 3 into its height 43.2 square. So let us see how much we get. .48 into 10 raised to power 6 plus 8.84 into 10 raised to power 3 into answer square. So I'm getting 19.95 into 10 raised to power 6. 19.95 into 10 raised to power 6 mm raised to power 4. So this is my moment of inertia about this line PQ for a semicircle. I hope this numerical is also clear. Coming to the last numerical for today's session, let's read its statement. It says, determine moment of inertia and radius of gyration of quarter circle of radius 600 mm about its own axis. So let us draw the quarter circle. The geometrical section now is a quarter circle. quarter circle, and let us say that its x-axis is running from here, x-axis, and y-axis from somewhere from here. Right, so this is my centroid G, this is my y-axis, and if I name this geometry, this quarter circle as A, B, and C, now AB is my base. From the base till this x-axis where the centroid is lying, this height will be coming equal to, from here to here, this height will be coming equal to 4r by 3 pi. This is where the centroid lies. Now we are asked to determine moment of inertia about its own axis. So moment of inertia about its own axis. So its own axis are the two axes which are x-axis and y-axis. So if I find moment of inertia about I-x-axis, it will be equal to 0.055 r raised to power 4. So the radius given here is 600 mm. It is already given in the question. So it will be equal to 0.055 into its radius is 600 raised to power 4. So this will be coming equal to, let's solve it in a calculator, 0.055 into 600 raised to power 4. So this is coming equal to 7.128 into 10 raised to power 9. So let's make it 7.13. 7.13 into 10 raised to power 9 mm raised to power 4. So for a quarter circle, I-x-x is equal to I-y-y. It is equal to 7.13 into 10 raised to power 9 mm raised to power 4. So this is, it will be same for quarter circle. Now next we are asked to find radius of gyration. Next we are asked to find radius of gyration of quarter circle about its own axis again. So if I find radius of gyration number 2, radius of gyration about its own axis, it will be equal to kxx is equal to root over of Ixx by its area. Now let us find the area of a quarter circle. It will be equal to pi r square by 4. So this will be equal to pi into 600 square by 4. It will be coming equal to pi into 600 square by 4. So this is coming equal to 282.74. 282.74 into 10 raised to power 3 mm square. So this is my area for a quarter circle. Now let us find radius of gyration. Radius of gyration will be equal to kxx was 7.13 into 10 raised to power 9 divided by 282.74 into 10 raised to power 3. So this will be coming equal to 7.13 into 10 raised to power 9 divided by its area. So it is coming equal to 158.79. So let's make it 159. It's coming 159 mm. Similarly, my KYY will also be equal to KXX equals to 159 mm. So this is it for today's session. I hope all the numericals, all the 5 numericals are clear to you, and let us meet in the next session.